In this video, I want to show you some examples of finding derivatives of inverse trigonometric functions. And so here are the list of the formula right here. Notice that we've got the derivative of sine inverse of u, and u will be a function of x again. So because we're finding the derivative with respect to x. And it is 1 over the square root of 1 minus u squared. Remember, we must always multiply by the derivative of u with respect to x, the du dx. Going over to the derivative of the cos inverse u, it is very much the same, but please note there is a negative in front. Okay, that's the difference there. Don't miss that negative. And then when you're jotting them down for the derivative of tan inverse of u with respect to x, is 1 over 1 plus u squared. So it's got plus instead of a subtraction, which is in the first two, and it doesn't have the square root sign. All right, so I suggest if you haven't got these in your notes, pause the video and jot them down. Okay, so just to refresh your memory, what is an inverse trigonometric function? Well, if you remember having something like sine y equals 8x. Okay, so y is the angle, right? And 8x is a multiple of the, 8x would be the sine of y. And so when you rearrange this to solve for y, you get a sine inverse function. So this means that y equals the sine inverse of 8x. Okay, so this is when we're finding the angles. This is what we do to find the angle. And now that I've refreshed your memory, maybe you remember this from first year. So let's take a look at an example for each one of these that will illustrate how we use this particular formula for inverse trigonometric functions and their derivatives. So here we have an equation. We're asked to find the derivative of y equals the sine inverse of 8x. And remember that our formula tells us how to find the derivative of sine inverse of u when u is a function of x. And that will be 1 over the square root of 1 minus u squared multiplied by du dx, right? So we have to make this part, which is the angle portion, or actually it's the sine ratio portion, and we have to make it equal to our u. So let's say u equals 8x. And the reason we need to do this, and also the second portion of the formula, is we need du dx. So right away, we might as well find du dx, okay? So this leads us to du dx. Well, the derivative of 8x with respect to x is just 8. Okay, so now we're ready for the derivative. So the dy dx, right? We're finding the derivative of y, it's the name of our function, with respect to x, will be equal to, and we have to look at the formula, it's 1 over the square root of 1 minus u squared. So I'm going to put my u in brackets, and that needs to be squared. And that is multiplied by the du dx, which is 8. Okay, so just to tidy this up, that 8 means over 1, right? So when we multiply fractions, let's see how this works out. Dy dx equals 1 times 8. I'm going to multiply these two. That's 8 over the square root of 1 minus, well, this square is on the 8, it's also on the x, 64x squared. And we're finished. All right, well, let's take a look at another one. This one is a cos inverse function. And so the cos-inverse function formula is there. And just remember, it's very much like the sine, but it has a negative in front. And again, this is our u because that's where it is in the formula, okay? So let's start by saying u equals 3x squared. We know we need du dx, so let's calculate du dx. 6x, right? Okay, so let's now do the derivative of y. That's the derivative of y, the dy dx is negative 1 over the square root of 1 minus, and we have to do u squared, so I'm going to bracket it, and multiply by du dx, which is 6x. To tidy that up, we do have a coefficient of negative 1 out there, right? It's multiplied by 1, which is multiplied by 6x, all in the numerator. So dy dx is negative 6x all over the square root of 1 minus. Now remember, we have to square the 3, and we have to square the x squared. And it's finished. Let's do one last one with the tan inverse function. So I've written the tan inverse formula here, and notice there's no square root in the denominator, and it is 1 plus u squared, but we always multiply by the du dx. So, well, we better find out what u is first, right? It's bracketed here nicely for us, so that is all u. U is equal to 5x squared plus 3. Again, we know we need du dx. Let's just write it down. 5x squared, the derivative of 5x squared is 10x. And the derivative of 3 is 0. So that's done. So dy dx is 1 over 1 plus, it's u squared. Remember I bracketed them before? Continue that. This is really important this time. That's all u, and it has to get squared. We need to multiply by du dx, which is 10x. All right, so just to tidy that up, that 10x is over 1, so now multiplying these two fractions together, 10x in the numerator, which is 1 times 10x, right? The denominator, 1 plus, okay, 5x squared plus 3 all squared. Let's do that over here. Okay, that's equal to 5x squared plus 3 times 5x squared plus 3. All right, 5x squared times 5x squared is 25x to the 4. 5x squared times 3 is 15x squared. And 3 times 5x squared is 15x squared. And 3 times 3 is 9. We've got like terms. All right, so now I have squared that. Bring that over into here because it's equivalent to what that is. I'm going to keep it in green just for now. 25x to the 4 plus 30x squared plus 9. We have one final thing we can do to tidy that up because we have like terms there. 1 plus 9. dy dx equals 10x over 25x to the 4 plus 30x squared plus 10. And that's how we'll leave it. And that's it for my examples of derivatives of inverse trigonometric functions. Thanks for watching.